Hey everyone, so we're still chatting about chapter 5, and this is actually called 5.1 extension. So if you see that anywhere, this is just an additional piece of 5.1 where we talked about 5.1, we talked about domain and range. And we also talked about these words function and relation, and actually it was in our notes from 5.1, and I want to point that out if you happen to notice it. Let me see here. It says in our definition of function, it's a relation. So what is a relation? That's what we're going to talk about in 5.1 extension. Before we do that, let's talk about what examples or ways to represent a relation. There's many ways. We can represent a relation as an ordered pair, a set of ordered pairs. Remember, we have these curly brackets. And we use curly brackets anytime we are listing things. So here's a list of ordered pairs. I put them in curly brackets. A relation can be also a table of x's and y's. Again, guess what? This can go to a point 2, sorry everyone. This can go to a point 2, 1. Right? These can all be points, just like in our set of ordered pairs. Something called a mapping diagram. One circle is your x's, the other circle is your y's, and the arrows between the circles represent what x goes to which y. So the 2 goes to the y, the 1. That's why it would give me the point 2, 1 that we see everywhere else. 3 to 4, guess what? That's our next point. And then lastly, as a graph, which we're very used to seeing, we've got points, 2, 1. That's that same point, 2, 1, that we've been seeing in the other forms. And not every relation is a function. In order for a relation to be a function, so a relation is just a set of points, that's all. But in order for a relation to be a function, every input value has to be matched to exactly one output value, and we're going to look at many examples of that. Let's look at this first example, problem 1. Use the graph table or mapping diagram to write the relation as a set of ordered pairs, find the domain and range, and then decide if the relation is a function, yes or no. So guys, the relation here, everything is a relation. A relation, I'm going to list our points, 2, 2.6, 4, 5.2, 6, 7.8. In our curly brackets, the list of points. The domain we talked about in 5.1. This is our domain, 2, 4, 6. Here's our range, 2.6, 5.2, 7.8. We know how to do that. Is this a function, yes or no? Does every x value go to exactly one y value? 2 goes to 2.6. 4 goes to 5.2. 6 goes to 7.8. Yes, they all go to different y values. Let's say, for example, we saw a table and it said 2 goes to 2.6. 4 goes to 5.2. 5 goes to 5.2. 6 goes to 7.8, and 6 goes to 5. The problem comes in right here. This x value goes to 2 different y values. That's our problem. This would not be a function. We're allowed for this to happen. This is okay. X values can go to the same y value, but the same x value cannot go to 2 different y values. It has to only go to 1. We're going to look at more examples, not to worry. So here's, we can list our relation, 1, 5, 2, 7, 1, 7, 3, 9, 4, 9. Our domain, 1, 2, 3, 4. Our range, 5, 7, 9. Our x's and our y's. So does every x value go to exactly one y value? And we can look at this. 1 goes to 5. 2 goes to 7. Oh, look at it right here. 1 also goes to 7. That's a problem. So we do not have a function. No, 1 is mapped to 5 and 7. Mapped means goes to or is another point, another y value. 1 is mapped to 5 and 7. We cannot have that. We can have this, that's fine. 3 can go to 9, 4 can go to 9, that's okay. The same x value just can't go to different y values. Let's check out this one. It's a mapping diagram. The arrows represent our points. So I've got 1/2, comma, -1/4 is a point. 1/2, comma, 0. 1/2, comma, 1/4. My domain is just 1/2. My range is these 3 values. Is it a function? Does every x value go to one y value? Well, no. 1/2 is mapped to 3 different y values, and we are not allowed to have that. Every x value needs to be mapped to exactly one y value. And here's our last example. Our relation, the points, 1, 2, 2, 4, 3, 4, 4, 5. Domain is our x values. Range is our y values. Is it a function? Yes. Because every, and we can write it down if we want to, every x value is mapped to only one y value. That's what we need to see. Okay. Oh, I have another example actually, just kidding. Here's a relation. It's another mapping diagram, 1, 2, 3, 2, 5, 7, 9, 8. Domain, here's our x's, range, here's our y's. Is it a function? Does every x value get mapped to exactly one y value? Yes. It would look like this, guys. It's actually really easy to recognize in a mapping diagram. If it goes like this, 1 goes to 2, 1 goes to 6. As soon as you see 2 things over here, not a function. We can have 2 over here, though. That's okay. And then let's check out, it says create a mapping diagram for the set of ordered pairs, then determine if the relation is a function. So I'm going to have my x's in one, my y's in the other. List my x's. I've got -5, 0, the first one, 5, 5, and 10. I'm not going to repeat it. And then my y's are 0 and 10. And then we're going to draw the arrows to connect our points. So I've got -5 goes to 0, 0 goes to 0, 5 goes to 0, 5 goes to 10, 10 goes to 10. So right away you can see, and you maybe heard it in my voice, where's the problem? It's not a function. Right here, this is the problem. 5 is mapped to 2 different y values. Okay, and then let's check out B here. Everything's drawn, the x's, the y's. The arrows go from the points. Yes, it's a function. Every x value goes to exactly one y value. So then we have something called the vertical line test. The vertical line test is a way for us to look at a graph and figure out if the graph represents a function. And so what we do is, guys, we draw vertical lines. If the vertical line passes through 2 or more points, then it is not a function. So let's check this out. I don't know, can I get a different color here? Yeah. If I draw vertical lines, here's my red graph. If it intersects exactly one time, like this intersects one time, one time, one time, one time, one time, it's a function. If I draw vertical lines here, intersecting twice, intersecting twice, intersecting twice, not a function. Okay, let's check out some other ones. Let's plot these points to figure out if it is a function using the vertical line test. I've got -4, 2, -3, 1, 0, -2, -4, -1, 1, 2. If we come through here and draw vertical lines, vertical line, oh, it's good, 1 point. Vertical line, 1 point. Vertical line, 1 point. Vertical line, uh-oh, passes through 2 points, not a function. What about C here, the next one? Vertical line, 2 points, not a function. Vertical line, vertical line, vertical line, vertical line, 1 point, yes, it's a function. Vertical line, vertical line, vertical line, vertical line, yes, it's a function. One time, one time, one time, one time. Whoops. And then let's answer this final question here. Do all linear equations represent functions? Think about it, guys. And just you could draw a couple linear, if here's a line or here's a line, here's a line. Think about it. Would all three of these be functions if you were to draw vertical lines through them? Intersects one time? Yes. Except, what line would not pass the vertical line test? A vertical line, guys. Because it would hit every single point on the vertical line, except vertical lines. Okay? Guys, that's our 5.1 extension. Great job on learning about relations, functions, and the vertical line test.